Hello, explorers, and welcome to Reach the World's Explorer program. For more than 25 years, Reach the World has inspired youth to become curious, confident, and compassionate global citizens through virtual exchange. My name is Tim, and today we're gathering to reflect on our journey through the world of supercomputers and research software engineering over the previous weeks. Joining us again is the Executive Director of the U.S. Research Software Engineering Association and Senior Researcher at the San Diego Supercomputer Center, Dr. Sandra Gesing. And she's brought a very special guest with her today as well. Today we'll meet Dr. Birali Runesha, who is the Director of the Research Computing Center at the University of Chicago. Birali has had an amazing career working with supercomputers and advanced research software engineering at institutions around the world. And we have so much to discuss today with these two incredible experts. Before I bring our guests on screen, though, I want to share a friendly reminder to the more than 850 students in 40 classrooms around the country who are following the journey live. There's a great selection of new articles on the Supercomputing and the Future of AI Journey homepage, which you can find using the link I've added to the chat area on the right-hand side of your screen. For any of our classrooms who may be joining live today, please add your questions for Sandra and Birali to the chat at any time, and we will fold them into the discussion. Okay, I think that covers our introduction. So with that, I'm very excited to welcome to the screen now today's special guests, Dr. Sandra Gesing and Birali Runesha. I will bring you up right now. Hello, hello.
Hello.
Hi.
Hi, it's great to see you both. Thank you so much for joining us today on our last live stream of this virtual exchange.
I'm happy to be here.
Likewise.
And Sandra, it's great to have you back. We started this journey together with you many weeks ago, and you told us about the amazing things we were going to discover as we met your friends and saw where they work and heard about their expertise. And wow, that's really lived up to your billing. I want to just real briefly reflect on that journey with you, and then we're going to turn to Birali and learn more about him. We started by just discussing generally what a supercomputer is. I think, everybody may have had different impressions of what the actual hardware of a supercomputer is. And we met Rick in San Diego, and he showed us the San Diego Supercomputing Center, and that was just incredible. What a cool thing to see.
Yes, and you have seen there that it's, a supercomputer is not one computer, it's a lot of computers together. So that is, as you have seen that there were the cabinets, a lot of blinking lights, and that was different architectures. And I remember that I got the question whether there is a Raspberry Pi. There was not directly Raspberry Pi, but that could be used for a lot of things to make it faster and build your own supercomputer. So, and remind you, but it's in here, really at computer power, was 30 years ago in a supercomputer. This is now in your mobile phones. So that is, and we are coming near to the borders of physical, what we can do on ships. Yeah.
I am reminded of the amazing supercomputing power at our fingertips every time I have a question and I ask my phone, and it searches the whole world for the answer in just a second. It's really astounding and cool to think about. We met a couple of your other colleagues who are showing us how their research software engineering is harnessing the power of these incredibly powerful computers to tackle questions in the real world, to do real world research, and have sort of got into why software engineering is so important too, that you have this big powerful thing that you need to tell how you want it to use its power. And did you have anything you wanted to sort of add to that? Because I know that's your real passion and expertise.
So really, software engineering research, software engineering especially, gives you the chance to explore so many other worlds, because if you develop software, you can do it, like you have seen the series about the wildfires. You can help really to locate wildfires, to prevent wildfires. How exciting is that? I'm not a researcher directly in that field, but I can help the software to do this. And you can do that for any challenges you are interested in, whether it's in health or you are interested maybe in the universe, you are in physics. A lot of the things nowadays really in research need research software. 90% of research needs research software. So exciting topics where you can contribute with software.
All right, excellent. Well, let's bring in Birali. Birali, thank you so much for joining us today. I am very curious to know more about you and what you do. Sandra always has such incredibly interesting friends and colleagues that have great stories to tell. So maybe you can just tell us sort of where your career started, how you got started in this world of supercomputing, and introduce yourself that way.
Thank you. I'd like to start by thanking you, Tim and Sandra, for the invitation. It's really a great pleasure for me to come and share my story. Actually, my story started, I was born and raised in Eastern Africa, where when I was a young boy, like any other kids around me, we love sports. Like when I see kids here in South Chicago, it's always about gathering about basketball or football. But in my case, I really dreamed about soccer. Soccer was the biggest thing. And everybody in my generation, if you had asked me at 15, 16 years old, I really wanted to be a soccer player. And my dream player was Karl-Heinz Rummenigge. At that time, Pele was a little older. So I had this big picture of Karl. And then what I wanted to do was basically go play. I didn't want to do anything, even though I was very good at school. And we attended this Jesuit school where my math teacher basically knew we needed some nice soccer ball. And then you say, okay, I'll give you math problems. Every time you get them right, I'll give you the right gears and balls and for you to play like professional. And we were excited about that. And we'll do that the weekends and Sundays and all the time. And then what I did not realize, I really developed the love for math and science. And all my colleagues, all of us, literally, we all went to college and we attribute that for that particular experience. And then did my undergrad, and then I got the chance to get the PhD, a scholarship to America. And then I landed here at 25, 24. And by the way, until then, I never touched a computer. So I touched my first real computer here in the US, and was I took a first class in math, got an A, but the second one, and the assignment was, you gotta write a program, and it's due in 2 weeks. And then I went to the teacher and said, I'm gonna drop this class, and then because I never touched a computer. I said, no, you can't drop the class because you're good at math and this and that. And then he basically gave me a chance to return my homework at the end. And then he became my advisor for science. And then fast forward, my thesis was really working on solving a problem using some machines at NASA Langley. And you remember there was a space challenger that was down. We were trying to reproduce the mode of failure. And then you really needed supercomputers. So you're talking about somebody never touched computers. I had to solve algorithm to reproduce that. That was my introduction to supercomputer. Basically, I spent my 6 years of my PhD publishing and writing and having access to supercomputers. And my degree was in engineering. And when I finished, I love software engineering. And it became my passion with high performance computing, which is what I do today, until I went work for various universities, and now at the University of Chicago as an associate vice president for research computing, a director of the Research Computing Center that, by the way, I created 13 years ago.
Amazing. What a journey.
Yeah.
I think that really resonates with kids who like soccer or insert other sport, but also sort of like math and science too. The two can work together in mysterious ways to motivate and inspire career paths.
Yeah.
Can you give us an example of a problem that your computing center has attempted to solve in the past, or is in the process of trying to solve using supercomputing?
Oh, I have many questions. So like usually centers like ours, typically you'll have a team that manage supercomputers, like what you saw at San Diego. But we also have a team of software engineers. These are people who have expertise in high-performance computing, as well as they understand the science. So take an example of a problem we worked on for some time was about prostate cancer. Today, prostate cancer is one of the killing for men. But what you do, people will go to the hospital, they do all this biopsy, but then we say, okay, why don't we just use imaging to be able to detect automatically without the biopsy cancer, for example. So we use computers train and use some AI algorithm to train some of those methods, and we're able to come up with something like a doctor who does not have an understanding of high performance computing can just point something on the image and on the MRI image and say, okay, this is potentially cancer. So that's just one example. We had also another one. I think you see extreme weather, like in a hurricane in Florida. We are at the moment trying to train some AI, some program, some model to be able to detect ahead of time, so that at least is it possible to detect some of those extreme weather before they do damage in an area, so that people can prevent. And I can have a lot of example in chemistry and proteins, and nowadays actually some protein engineering is a really big topic. We have also traditional, like my background in engineering, structural engineering. When you do simulation of fluid dynamics or crash, those are all very good applications of high performance computing. And by the way, it's really a combination of software engineering, like Sandra was saying, and then having access to machines.
Okay, you mentioned casually AI in there, and I want to talk just a little bit about AI because it's something students are really interested in. We all, in this day and age, we as consumers can use AI in kind of fun and exciting ways, whether it's just making a silly picture or helping us write something. It's becoming more a part of everyday life. And you mentioned that you're training models, AI models, in your computer center. What does it take to train an AI model? What does that look like when we hear somebody say that?
Yeah, so good question. Maybe before I can answer that question, let me back up a little bit about AI. So artificial intelligence or machine learning existed for some time, but what made it actually become such a big deal now was really a combination of three things: is ability to have access to data, so, and then the ability to also have access to computers that can do that kind of computation, and also the expertise, the algorithm that were mature enough to do that. Basically, what we are trying to do is, instead of solving, let's say you have an equation, you solve it exactly, or a differential equation, you do a numerical analysis. AI instead takes a bunch of data and say, okay, can you learn the pattern in this data to be able to say, okay, you're able to predict something? That's when we talk about training, is basically you are feeding it a lot of data. The more data you can feed it, the better it is. And then you say, okay, you've learned the pattern. Maybe I say, if I give you the data that I did not give you before, can you be able to predict something? So when I say about training, basically that's what I mean. Basically, we are really using the algorithm. Can you find those pattern and association and so forth? But what made it possible is something you're gonna hear a lot, is the term like GPUs. And many of, I would imagine, students listening, they might be playing games. So in your computer, there's like a graphics card. It's when they realize that those graphics cards can do computation and accelerate the computation due on the CPU, that's what made AI really explode. So basically what we do, we basically buy a bunch of all these graphics cards, even though the supercomputer you visited, inside is really about those GPU, but can you put them all together to work on one problem so that you can speed up the training? The training really takes a lot of time, sometimes in weeks. Like the example I was giving, it would take really weeks to run those calculations. And then once you train it, then the rest become inference, which means then that's when you start really asking questions. And this is what is really also fueling and driving what's behind, even when you do ChatGPT and so forth. There's really a model that was already trained, a large language model that was trained before you can start really doing those inferences.
Okay, very interesting. My next question is for both of you, really, as experts in this field, in this genre of topics. What gets you excited about the future of supercomputing, AI, research software engineering? What do you think, 10 years from now, we're going to be looking at when we think, maybe we're watching this, maybe it's 10 years in the future and someone's watching this conversation we're having. What do you think is going to be either the most sort of groundbreaking use of this technology or some new thing that's going to come from it?
So maybe I start and then give Birali the stage again. So I think what is very exciting that first of all, we have all these different kind of computers now, different hardware, what Birali mentioned with GPUs, but we have also quantum computers. So you might have seen the report and there might come still also a video up, so it's a totally different computer. So we can solve with quantum computers and AI probably problems we cannot touch at the moment because it takes too much time. It would take too many resources. It would take years to be able to run a simulation, for example, about certain simulations for climate. We know if the larger the data gets and the more complex the problems, the more, also AI has to think about it. It has to learn. So when you think about AI, and probably Siri on your phone or, Alexa, they have a lot of learned knowledge from, the internet. But models and simulations are working a little bit also with specific data. That is where the more data they become, the more that they get, the more they learn. And that means I think we will have an exciting AI landscape in 10 years. I also think that, programming, it might be not directly like in enterprise, in the universe, but you might have seen on on TV that it's like you probably can speak to your computer and say, make me this nice little software piece, but I have to check them. As a software engineer, you have to check them whether it does really what it expected to do. Because AI has, for example, AI has hallucinations. It's like information that is not really coming because of the learning process. Some things are going on, or it has something like that it makes wrong assumptions. So that is one of the lessons. Everything that comes out of AI has to be verified. And I think what will be exciting for research software engineers, there are so many different options. For example, if your favorite is maybe not math like Birali's, you can still be in research software engineering, for example, around usability. Do something like UX, really that tools are more usable. When you're in the internet, sometimes you see these tools where it's like, oh yeah, I can click around here, or you have a game, and you know very intuitively what to do. And sometimes you see websites where it's like, I don't know what I should start here and what it is for. That is exactly where you use research software engineers who are usability, who make it nice, usable. And I will also help with that. So I think there are a lot of the supercomputers will be able, with the different architectures and methods we have, to even work with more data and also simulate things we cannot simulate nowadays yet. So it will go in a different dimension. But I think research software engineering will have also a different dimension. It will be always important that research software engineers exactly understand what they're doing. Even if AI gives you some program code, you have to verify that it really does what it should do.
Okay, before we go to you, Dr. Runesha, there's a great overlap here between this program and topic and other Reach the World programs that we've done where we've followed researchers into the field who are collecting data on climate change. And it's that data, which we talk about, well, what are you going to do with it now, that can come back and inform these models and help us solve some big global problems. It's a very interconnected moment for me hearing you speak, Sandra.
Great.
And Dr. Renusha, how about you? What are you excited about for the future of supercomputing?
Yeah, thank you. I mean, for me, the excitement is like a kid who's ready for Christmas, or the present that can see the potential. We haven't really scratched the full potential of AI. I think when I think about what's going to be possible, that's what really excites me, and also the ability to do things that were not possible to do. And when you look at AI today, we started really doing the traditional solving, just training through using data. But what's excites me the most is when now we start really adding reasoning. For example, can AI start reasoning like a human? For example, can he start really having logical conclusions, and then like really learning the physics, and having more be real? For me, that's where the excitement really starts. And then there's also this new concept you're going to hear quite a lot in the days to come, is what they are coining to be agentic AI. Because when you think of AI so far, it's really kind of look at one problem at a time. But when you want to like train all those agents together, that's where you add the complexity, but then you are able to solve things more realistically. And then, like also Sandra said, we are really close to the hardware, and then some of us who manage systems, and the integration of quantum and AI to accelerate and do big things that were not otherwise possible. The world is really, when I say excited, is really, for me to do that is really exciting in my lifetime. Because one thing I didn't mention, when I was a student, I used punch cards. That's what we would give a bunch of cards, and then after that, I've seen the evolution from punch card to floppy disk to 3.5, and all the way now you have all kind of media. But then there came even the time of internet and the mosaic at Urbana-Champaign, and now AI is changing all the world. So to be part of all these changes is really, when I reflect back, is like I can never have thought I would go through all these changes. But I'm just going to add by one thing though. As much as I'm passionate about AI, sometimes I wake up also more to worried about AI. What do I mean by that? Because like Sandra touched on this a little bit. How do you trust what AI is giving you? There's all these ethical issues, because like I say, I train it with the data I give it. I can also feed it the wrong data because I want it to do something that might not necessarily ethically be right or the right thing, or create some biases in what it does. That's where really, even though we are innovating, we need to understand how we're going to continue to make it trustworthy, reliable, ethical, and then to be able that is really contributing to our social good.
Excellent. Thank you both for your perspectives on that. I have a question from our friends in Brooklyn at PS1 for you, and it's more about you and your career paths. Both of you are very senior and experienced in your fields, but they're very curious to know if there was ever a time where you wanted to give up your work, whether you thought, it just wasn't going to work for you, and why didn't you give up? Why did you stick to what you were doing?
So I can start with that one. So I started with an apprenticeship in Germany. That was good for me. I had some work in industry, but I was like, yeah, I would like to explore it more. So that was then doing my master's besides work. And I have to say this, working and doing the master's, there were some times in between where I was like, oh, that is a little bit overwhelming. Um, why I didn't give up, first of all, the topics were really interesting. And I had a good group of co-students who did it the same way I did, besides work. And we would meet often every week on the weekend and just support each other. So it was really support from friends, from having a study group to work together on that. Nowadays, I would not change the trajectory. For me, it was fine to do it besides work, but there were some situations where I was like, this is now too much. But yeah, friends and co-students brought me through that.
All right, great message. And Birali, how about you?
Yeah, I think there's one moment in my life I remember very vividly. It was when I was doing my PhD thesis. I was thinking a year or 3 or 4. basically you are a student, wake up every day, go in the lab, writing, and I felt like, and then I was having a problem solving that. I did not get the right result. Everything I was trying was not giving me the right. I was like, what am I doing here? And at the same time, there was a friend of mine, a very good friend of mine. We did the couple of years after the bachelor. In Finnish, he decided to go work. And he would come drive. He bought this red Corvette. It was like basically he was doing well. I mean, in those standards. And here he would be buying me lunch, and because I was still a student back then. And then there were times really you ask yourself, maybe he's just enjoying very good life. What am I doing? But then what drove me, like you said, like Sam was saying, I really love what I was doing, and I was really determined to say, I know I can find it. I know this way. So there was not enough money to it, but I was happy doing what I was doing. I mean, of course, my friend, it's not like he was not highly happy, but he was doing with love. But fast forward, I'm still in touch with a good friend, but his life kind of stagnated because he did not go anywhere. But when I look at my progression of life, because I continued to do what I would love to do, at one point it became remunerative, which means I got good job, and then I started quickly progressing. So the message I'm saying is like the passion and the love was the thing that really kept me going, which is in retrospect is really what I would advise anybody to do.
Okay, you treated your career like a marathon instead of a sprint. Is that another way to say it?
Yep.
Excellent. Both of you, I'm struck by how both of you have gotten education and work experiences in places outside of the United States, that this is a field that certainly does not only happen in the United States, that if you want to live and work in another country, the field of supercomputing and research software engineering is sort of there's a global need for people who know what they're doing in that space. Can you talk a little bit about how your travels and your having worked within different cultures and different global contexts has helped you with your job?
So yeah, I did my PhD in Germany. You had that in the first series. But during that time already, I would go to different conferences as a PhD student, or I would have a really close collaboration with the University of Edinburgh, because often also working on certain problems, there is a community worldwide. And so in my own group, there were not other PhD students working on the same problem. So, but I could discuss my problems then with other people outside, besides my advisor, of course. So that made it exciting. That I felt like, oh, I'm not the only one who has some struggles here to find the next steps and everything. So, and then for me, it's very exciting to visit also other places. So one part was really to meet with collaborators. And then I really like going to conferences. I was this year already, and it's only end of April. I was at 7 conferences this year. And just last week in Puerto Rico, and Tim was also there. And Birali and I were at Globus World in Chicago before. So it's having really the chance to discuss with people, but also to experience other cultures. I think it's very exciting. It's like I always try to see also a little bit around. It does not always work out, but different cultures. Also learning maybe another language. So my mother tongue is German, and I'm living now in the US 11 and a half years, and I speak English. And it has brought me, my research has brought me all over the world. So I looked it up. I not only for work, also it was also some private travel. But I visited 34 countries in my life by now. So it is exciting to see how other people live, how other people approach problems. So I think it opens other perspectives, and let's see as not everything has to be how we do things at home. So I think it's nice to see other cultures, learn from other approaches, and have also the research community worldwide.
Great, thank you, Sandra. Birali, how about you?
Yeah, like I said, I did my undergraduate in Africa, and then actually my PhD was in the US. So I had the chance to benefit from both worlds. Like Sandra indicated, I think I did appreciate the role of different culture when I started working, because a lot of our work involved a lot of traveling to conferences and presenting your work. And then throughout my career, I also had the opportunity to work for 2 years in Hong Kong, of all places, which was also a different experience for me. It exposed me to also interact with a lot of universities in Asia. But what I said, I think I took from it, I continue to cherish for me, it was the ability to explore how, like Sandra said, how people approach problems, the problem solving, and then the critical thinking. I think one of the things we don't appreciate is when you even working on a problem and you find a colleague, you can discuss that problem. Quite often you will find through those discussion a solution, and it will help you think through the process. And for me, those are the things that I really value a lot in those exchanges. And even at conferences, we sometimes will be gathering, and it's sometimes even through social, a drink or something, but we'll revolve back to talking about science or problems in those gatherings. And then you always come back with something that you learned that you did not know when you went in. And I think for me, this is something you don't get in a classroom settings. You don't get into basically anywhere. I remember, I don't remember what it was a French writer, I believe. I think life is a perpetual learning. And on that one, the perpetual learning, if you can be exposed to different culture, for me, it's even get richer learning, I think. That's what I would say.
Fabulous. Thank you both. I want to pause briefly for a completely different subject, the subject of unicorns. We're going to go from great global learning and amazing sort of interconnectedness amongst colleagues around the globe in the supercomputing space. And Sandra, can you tell us a little bit about the unicorns that our classrooms have received from you?
I wanted to say, so the first 15 classrooms which signed up got a unicorn, a little stuffed unicorn, and the unicorn, we like to use it as our mascot, or it's our mascot, because what we recognize, so we started with USRC in 2018, and we all had our own, little journey to be a research software engineer, because by now there are not many career paths, that you have the opportunities to become a research software engineer directly. That has changed in the last 7 years already, which is really great. But we always felt like, me coming from industry first, with my 12 years of industry experience and doing my PhD, and switching between worlds and being a researcher and recognizing that I still love creating software. So I'm a research software engineer and a researcher, and the unicorn. And there are many stories like this, that people felt like, oh yeah, I'm now in this national lab, or at this university, but I don't really fit totally in the surrounding that I should be a postdoc, or do my PhD. But I really like to contribute via software, and so we chose the mascot because we are a herd of unicorns. They're very. So I hope you enjoy your unicorns.
Yes, thank you for sending those. What a great metaphor for all of them. We've heard many of them on this journey alone, all the different ways that people come to this field. Birali, you were saying you liked math, you got good at math, and it sort of flowed through engineering and then to computers in your 20s. As just sort of general career advice for the students who are watching this, who have been on this journey with us and think, what Sandra does, what Birali do sounds really cool. I'd be interested more. What sorts of things could they do, try, pursue in the coming years as they go on to high school and college that would position them really well for a career in research software engineering, or a job with supercomputers and sort of the future of computing?
Mm-hmm. I think the advice might be really simple, and I think maybe can be, in particular when you're in high school, sometimes you don't understand the relevance of why am I learning math or some of these abstract concepts. I think some of those are foundational, which means those are the elements that help you forge your critical thinking. I think for me, you need to take those basically when you're going to class, basically um, just explore a lot of those courses and take them. Each class that you take it seriously and try to do the best you can. That's number one. The second one, I think for me, is what I really believe has always been the biggest in my view, that is love what you do. And then once you love what you do, you will have that passion and the drive. And typically, I've always said, for me, any career, if you have the love and the passion, you can become a millionaire. You can be a best, or you can with it. Even going cooking or being a girl, it doesn't. It's all about really the passion, because that helps you discover even the tool and the energy that you will not even think that you are even capable of being able to. And when you love that, that always tell yourself, nothing should not be say. Nobody should tell you that you cannot do anything. You should be able to do whatever you set your mind on, because all of us, we studied not even necessarily computer science. We are ending doing something is because of that love and picking up all those skills. It becomes really the trajectory. You get the foundation, what you love. Basically, you can create what you want to become and move forward. And the last one is, sometimes also always believe you also have to be pragmatic in this world, meaning it should not be the driver, but there are sometimes when you make some of the choice and the passion is something that can also provide the ability to have a living. Because sometimes those choices come back to say, okay, if I've taken this path, that I could have been able to do. Have an understanding of the world out there, the world that may be lucrative for what you do, just that understanding. And then knowing also what your level of quality of life will also be helpful. What do I say that? At some point, I mean, I didn't mention this, I love philosophy, but philosophy cannot make you. When I tell my dad, he's like, uh, you're not going to make a career being a philosopher, for example. But what he always tell me, I say, son, continue actually. It will help you think critically. But pick also something else that it can help you pay the bills, or But he never told me to not do it, because you also need the humanities and all that. Actually, a person who's really well-rounded need to have all of that, because sometimes in my science, it's not like I use my reasoning. It really comes from those logical reasoning that we study in philosophy. So basically, that's what I meant. Those are the three things I would say.
All right. Thank you. Anything to add, Sandra?
I would second also, Birali, and definitely find something you really like to do, because that I think makes us really also happy people, Birali and me, that we, it's nice to do something that you love. Computer science, research, software engineering pays well. It's not something, if you can find jobs all over the world. And the other thing is what you could do already now. There are many things out there, also to look into, maybe starting a little bit programming, finding out whether you like it. There are good on the internet, some classes. Happy to share more about that. Where you can try just rudimentary things to see how it works. So problem solving, critical thinking are the best. Mathematical, logical thinking is also important. So I think, yeah, find out whether you like it or could like it, and then I think the next step is really, I hope in a couple of years you can apply all over the place for research software engineer jobs.
Well, that is great advice. And from my outsider perspective, it seems like a wonderful time to pursue a career path in this field, because it's changing, it's evolving. There will be lots of jobs in this field in the future and to come. So It's wonderful to have your great perspectives on that topic, and thank you for your knowledge and your inspiration today as we sort of bring this virtual exchange journey on supercomputing and the future of AI to a close. I'm going to just sort of wrap it up by saying, unfortunately, that's all the time we have today. This does mark the end of our incredible journey, and I hope that you've all learned as much from Sandra and her colleagues as I have, and that when we harness the power of supercomputing in our everyday lives, we'll all have a deeper appreciation for the hardware, the software, and one of my takeaways is the people behind the incredible technology that we use or that are powering discovery in our world today. Maybe you, our students, will be the next great research software engineers who help to make those great discoveries. I sure hope so. And until then, please keep exploring. Thank you so much for going on this Reach the World journey with us. And I want to say a special thank you and goodbye to Birali and Sandra for joining us today. And thank you to all of the members of the greater research software engineering community who have contributed to this journey. So thank you very much to you both. And I will see you again soon.
Thank you.
Thanks. Bye.